Hi students, welcome back to our channel. This is Panikumar, Senior Lecturer in Chemistry. In this video, we are going to discuss about the oxidation number. We are going to discuss about oxidation number. What does it mean by oxidation number? So during the formation of molecules from the elements, what happens means some of the elements may lose the electrons or some of the elements may gain the electrons. So that number of electrons which are lost by an element or that might be gained by an element is simply called as oxidation number. Oxidation number means nothing but the number of electrons lost or gained by an element during the formation of a molecule. When the elements forms molecules, during the formation of molecule, some elements loses the electrons and some elements gains the electrons. That number of electrons either lost or gained by an element is simply called as oxidation number. So we have to remember two different points. Number one, the maximum oxidation number of an element. The maximum oxidation number of an element is equal to its group number in Roman letter. Its group number in Roman letter. The maximum oxidation state is equal to group number in the Roman letter. In generally for P block elements alone, the minimum oxidation number is equal to group number in Roman letter minus 8. And this formula is not applicable for the fluorine and aluminum cases, right? And next, even for the D block elements also, the maximum oxidation number is equal to group number in Roman letter, right? So these 2 points you just remember. The oxidation number of any element should not exceed its group number in the Roman letter, right? So during the calculation of the oxidation numbers, what are the different points we have to remember? Okay, what are the rules for calculating the oxidation number? What are the rules for calculating the oxidation number? What are the rules for calculation of the oxidation number? Here, generally, what we can say means the oxidation number of 1A group elements is always equal to +1. You have to remember the first rule. Oxidation number of 1A group elements is always +1. What are 1A group elements? You know the 1A group elements. What are they? Lithium, sodium, potassium, rubidium, cesium. For these elements, the oxidation number is always equal to +1. Next, second point. The oxidation number of 2A group elements is always equal to +2. Okay, the oxidation number of 2A group elements always equal to +2. What are 2A group elements? Beryllium, magnesium, calcium, strontium, barium. For these elements, the oxidation number is always equal to +2. Next, you have to remember oxidation number of aluminum. Oxidation number of aluminum is +3. What is the oxidation number of aluminum? The oxidation number of aluminum is +3. Next, oxidation number of any element. Oxidation number of any element in native state. Native state is 0. Oxidation number of any element in a native state is 0. That means the oxidation number of native state means H2 at STP conditions in which state that exists. H2, Cl2, Br2, like this. Okay, like this are given. Then the oxidation state is 0, S8, P4, like this. For all these elements, the oxidation number is always equal to 0. Next point you have to remember, oxidation number of elements alone is 0. Again, oxidation number of elements alone. If an element is present singly, then its oxidation number is also equal to 0. For example, if I write H, Br, next Fe, Cu, Au, like this, if I write, then the oxidation number is equal to 0. If a single element is there, nothing is there to take the electron to give the electron, right? So if nothing is there in the bond formation, the oxidation number is equal to 0. Next, sixth point you have to remember, oxidation number of any metal. Oxidation number of any metal in amalgams. Amalgams means nothing but metal plus mercury is 0, right? Oxidation number of any metal in amalgams is equal to 0. For example, if I give sodium amalgam, NaHg, in sodium amalgam, oxidation number of sodium is 0, oxidation number of mercury is also 0. Next point, oxidation number of metals. Okay, oxidation number of metals in metal carbonyls. Metal carbonyls is 0. Okay, oxidation number of any metals in metal carbonyls is 0. That means if I give tetracarbonyl nickel, NiCO taken 4 times. Here the nickel oxidation state is 0. Pentacarbonyl iron is given, FeCO taken 6 times. Here the iron oxidation state is 0. So these are the conditions where the oxidation number of elements will become 0. And another condition is also there, oxidation number of elements in interstitial compounds. Interstitial compounds is also 0. So these are the maximum conditions where the oxidation number of elements will become equal to 0. Next point, let us discuss about the oxidation number of hydrogen, right? What will be the oxidation number of hydrogen? Here, hydrogen exhibits different kinds of the oxidation states. So in native state, that means as H2. In H2, the hydrogen oxidation state is equal to 0. Next, occluded hydrogen oxidation state is also equal to 0. Next, when hydrogen combines with the metals, that means either with 1A group elements or 2A group elements, then it exhibits a -1 oxidation state. When hydrogen combines with metals, it exhibits which oxidation number? -1 oxidation number. Next, common oxidation number of hydrogen. Common oxidation number of hydrogen is equal to +1. In general, we have to take the hydrogen oxidation number +1. If at all, if it combines with the metals, its oxidation number will become -1, right? Next, let us discuss about the oxidation number of halogens. Generally, the common oxidation number of the halogens, is equal to -1. When common oxidation number of the halogens is equal to -1. If halogen combines with highly electronegative elements, that exhibits a positive oxidation state. Next, in native state, that is as X2, the oxidation number is 0. Here you have to remember that is fluorine. Fluorine is the only element having one oxidation state. Okay, it is having only one oxidation state, that is -1 oxidation state. Fluorine does not exhibit positive oxidation states. Right? Next point, what you have to remember is oxidation number of the oxygen atoms. Here, generally, common oxidation state of the oxygen is -2. Okay, what is the common oxidation state of the oxygen? The common oxidation state of the oxygen is -2. If we take the peroxides, the oxidation state of the oxygen is -1. In peroxides, what is the oxidation state of the oxygen? In peroxides, oxidation state of the oxygen is -1. H2O2, Na2O2, BaO2, like that. Next, in superoxides, if we have considered the superoxides, oxidation state of the oxygen is equal to -1/2. Oxidation state of the superoxides is -1/2. Superoxides are generally formed by the combination of 1A group element with oxygen atom. Next, in suboxides, it shows -3/2 oxidation state. Suboxides, -3/2 oxidation state. Oxygen shows a positive oxidation state. It shows which oxidation state? Positive oxidation state when it combines with the fluorine. Most important point you have to remember. If oxygen combines with the fluorine, when it combines with fluorine only, it shows the positive oxidation state. And generally, as O2, in O2 native state, oxidation state of the oxygen is equal to 0. Right. Next, the sum of the oxidation states of all elements, the sum, SUM sum of oxidation states of all elements present in a molecule is equal to 0, or equal to the magnitude of the charge present on it, magnitude of charge present on it. What we have to do? The sum of the oxidation states of all elements in a molecule is equal to the, what we can say, magnitude of the charge present on it. Next, last point you have to remember, the oxidation number of any element calculated in this process should not exceed its group number in Roman letter. If the oxidation number calculated obtained more than the group number in Roman letter, that is wrong, and then we have to calculate it again. The example for this point I will give you while I am explaining CrO5. So first of all, just look at this board and just read all these points. Take a screenshot or something. Just preserve these things and here simply remember these rules. Just have a look at these points, friends. Okay friends, those are the rules for calculating the oxidation number of the elements. So here, while working out or while calculating the oxidation number, what we have to do? The element whose oxidation number we have to identify or calculate is taken as X. Here in this video, now I am going to explain about different examples also I will provide. Please practice them carefully. Right. So here let me say, here OF2 molecule is given. In this he asked you to calculate the oxidation number of oxygen atom. So I don't know the oxidation number of oxygen, so I assumed it as X. Right. I told you the oxidation number of fluorine is always equal to -1. Right. So two fluorine atoms are there. 2 into -1, -2. X minus 2 is equal to the sum of the oxidation numbers of all elements in a molecule or species equal to magnitude of the charge. Here 0 charge. X minus 2 is equal to 0. So X is equal to +2. So here the oxygen is having +2 charge. In O2F2, how many oxygen atoms are there? 2 oxygen atoms. So let me take 2X, 2 fluorines, -1 oxidation state, 2 into -1, -2 is equal to 0. 2X is equal to 2, X is equal to +1. So the oxidation number of the oxygen is equal to how much? +1 it is. Next, K2Cr2O7. I have to calculate the oxidation number of chromium. I told the oxidation number of potassium, that is 1A group element, always equal to +1. 2 are there. 2 into +1, 2. Plus 2 chromiums are there. 2X. 7 oxygen atoms. Each oxygen atom is having oxidation number -2. So 7 into -2, -14 equal to 0. So 2X minus 12 is equal to 0. 2X is equal to 12. X is equal to +6. Right? So here chromium I have to calculate in Cr. X minus 2 is equal to 0. X is equal to +2. Right? Next, here 2 chromiums are there. 2X minus 6 is equal to 0. 2X is equal to 6. X is equal to +3. Here chromium is having +3 oxidation state. And in CrO3, chromium I have to find. X minus 6 is equal to 0. X is equal to plus 6. CrO5, I told it is the most important example. X minus 10 is equal to 0, then X is equal to plus 10. Actually, the chromium belongs to 6th B group in the periodic table. So, the maximum oxidation number of the chromium is plus 6 only. But here we got plus 10. So, it is wrong. The most important model, my dear friends, listen carefully. If the oxidation number of any element calculated in this process is obtained more than its group number, we have to assume that the molecule is having a peroxide bond. If one peroxide bond is there, two oxygen atoms are having minus 1 oxidation state. I told in peroxides oxygen is having minus 1 oxidation state. So, let me assume one peroxide bond in the CrO5 molecule. Then what happens? Out of 5 oxygen atoms, 3 are having minus 2 oxidation state, 2 are having minus 1 oxidation state. So that X minus 6 minus 2 is equal to 0, then X is equal to plus 8. Again it is obtained more than its group number. Then again, you just assume another peroxide bond in the molecule. That means 2 peroxide bond. I told if one peroxide bond is there, 2 oxygen atoms are having minus 1 oxidation state. If 2 peroxide bonds are there, 4 oxygen atoms are having minus 1 oxidation state. So that out of 5 oxygen atoms, 4 are having minus 1 oxidation state, 1 is having minus 2 oxidation state. So, X minus 4 minus 2 is equal to 0, X is equal to plus 6. So, the oxidation number of the chromium is plus 6. Okay, let us go for the next example. Either O3 or O2. If any element combines with the same element, the oxidation number resultant to that bond is equal to 0. Right? Now, in O3 and O2, oxygen atoms are bonded together. So, all are having 0 oxidation state. Here, I want to calculate the oxidation number of magnesium. Or oxygen, let me say. Magnesium belongs to which group? 2A group element. So, 2 minus X is equal to 0. Right? Sorry, 2 plus X is equal to 0. X is equal to minus 2. Here in H2O2, I need to calculate the oxidation number of oxygen again. Each hydrogen is having plus 1 oxidation state. So, 2 hydrogen, 2 plus 2X is equal to 0. 2X is equal to minus 2. X is equal to minus 1. In KO2, oxygen oxidation number I have to calculate. 1A group element is potassium. So, 1 plus 2X is equal to 0. 2X is equal to minus 1. X is equal to minus 1 by 2. It is a superoxide. Next, Mno4 minus. I need to calculate the oxidation number of manganese over there. So, here what happens? X minus 8 is equal to minus 1. X is equal to plus 7. Right? Here in ammonium, nitrogen. X plus 4 is equal to plus 1. X is equal to minus 3. In Al2 minus aluminium, X minus 4 is equal to minus 1 because the magnitude of the charge is minus 1. So, X is equal to plus 3. Mno4 minus 2, manganese we have to calculate. X minus 8 is equal to minus 2, X is equal to plus 6. H2SO5, I need to calculate for the sulfur. 2 plus X minus 10 is equal to 0, right? X is equal to plus 8. It is again wrong because sulfur belongs to oxygen family. Maximum oxidation number is +6. It is obtained. +8. It is wrong. Then what you have to assume? You have to assume a peroxide bond. Then if one peroxide bond is there, out of 5 oxygen atoms, 2 are having -1, 3 are having -2. Then 2 plus 2 into -1 plus 3 into -2 is equal to 0. 2 minus 2 minus 6 is equal to 0. Okay, x plus, right? Then x is equal to +6. So the oxidation state of sulphurine H2SO5 is +6, right? Next, H2S2OA. We have to calculate the oxidation number of sulphurine H2S2OA. 2 plus 2x minus 16 is equal to 0, right? 2x minus 14 is equal to 0. 2x is equal to 14, x is equal to +7, right? But it is wrong because the sulfur belongs to which group? 60 group, I told. So it is more than its group number in Roman letters. So for this kind of molecules, I will give you some other hint also based on the structure. So 2 sulfur atoms are there. Each sulfur atom is having a OH bond, double bonded O, double bonded O, double bonded O, double bonded O. So how many oxygens are completed there? 6. So it is having SO, peroxide linkage. So if one peroxide bond is there, 2 sulfur atoms are having, 2 oxygen atoms are having -1 oxidation state. So what can I write? 2 plus 2x minus 2 minus out of 8, 2 are having a -1. So remaining are having -2. -12 is equal to 0. Then 2x minus 12 is equal to 0. X is equal to +6. Right? This is the oxidation state of sulphurine H2S2O8. Next, this is also most important complex repeatedly asked in different competitive examination. This is called brown ring complex. In brown ring complex, iron oxidation state. Here, the resultant oxidation state of NO is +1. Sulfate ion is -2. Water molecule is 0, right? Now, x plus 0 plus 1 minus 2 is equal to 0. Then what happens? X minus 1 is equal to 0. X is equal to +1. Next, N3H is called as a hydrozoic acid. So, 3x plus 1 is equal to 0. Here nitrogen I need to calculate. So 3x is equal to -1, x is equal to -1 by 3. Next, tetracarbonyl nickel. So this is carbonyls. Metal carbonyls, I told the oxidation number of the metal is 0. Either nickel or chromium is having 0 oxidation state in this molecule. Here, chlorine I have to calculate. 1 plus x minus 8 is equal to 0, x is equal to +7. Chlorine belongs to 70 group, so it is having that oxidation number, no problem at all. In NH3, x plus 3 is equal to 0, x is equal to -3 for nitrogen. Next, H2S. 2 plus x is equal to 0, x is equal to -2. -2 is the oxidation number of sulfur over here. Just have a look at these examples. If you want, take a screenshot or else practice yourself. Now let us see few more examples in which more than one kind of one element is present. More than one element is present whose oxidation number we have to calculate. So let us see here. We are having acetaldehyde molecule over there. We are having acetaldehyde molecule. Acetaldehyde molecular formula we know, that is CH3CHO. I have to calculate the oxidation number of carbon atom over there. So what I have to do? Simply here this carbon is bonded to 3 hydrogen atom. We know that each hydrogen is having +1 oxidation state. So the oxidation number on this carbon atom due to these hydrogens is -3. I told you one more point. If an element is bonded to the same element, the resultant oxidation number is 0. So the oxidation number due to carbon-carbon bond is 0. So here due to hydrogen is +3. So this carbon atom is having a -3 oxidation state. Why the resultant oxidation number becomes 0 if a bond is formed between two same elements? Means if two same elements are there, there will be no transfer of electrons. So the resultant oxidation number will become equal to 0. Now here due to this oxygen is having -1, this is having +1. So the net is -1 due to these two. So the oxidation number on this carbon atom is +1. So here -3, here +1, right? The average oxidation number, one carbon atom is having +3 oxidation state, -3 oxidation state, one carbon atom is having +1 oxidation state, and the average oxidation state will become -2 over here. In the same way, let us calculate the oxidation number in acetic acid. Due to these hydrogens, +3 over here, so -3. Here -2, here -2, and here it is +1. So due to OH, -1. So total -3. So this is having +3. So one carbon is having +3 oxidation state, one carbon is having -3 oxidation state, and the average oxidation state will be 0. And here in NH4NO3 molecule, it is of two different species, NH4 plus and NO3 minus. So here X plus 4 is equal to +1, so X is equal to -3, right? So -3 over here. Next NO3 minus, X minus 6 is equal to -1, X is equal to +5. So here +5, right now. Next in NH4NO2, same NH4 plus means -3, NO2 minus, so to minus, X minus 4 is equal to -1, X is equal to +3, -3 and +3 over here. In hydrozoic acid, if average oxidation state of the nitrogen is asked, 3x plus 1 is equal to 0, x is equal to -1/3. If individually they asked, this nitrogen is bonded to two other nitrogens, so here 0, here 0, due to this 0, here +1, so this nitrogen is having -1. The most important question, oxidation number of chlorine atoms in bleaching powder. This is the structure of bleaching powder. Here due to this oxygen, calcium is having +2, so here it contributes +1 to this one. Here this is having directly bonded to the calcium, so this is having -1. Here -2, +1 contribution from the calcium, so this is having a +1 oxidation state. In bleaching powder, one is having +1, another one is having -1. Okay, did you understand? Now let us see the Ki3 molecule. Let us observe the oxidation number of iodine in Ki3 molecule. So in Ki3, the original form is Ki plus I2. In I2 we know that it is 0. In Ki, potassium is having +1, iodine is having -1. And in FeS2, it is actual form is FeS plus S. this sulfur is having 0, iron is having +2, so this sulfur is having -2 oxidation state over there. Next, H2S5, this is the structure of H2S5. So these middle 3 sulfurs are having 0. This hydrogen is having +1. So this terminal sulfur is having -1 and this terminal sulfur is also having -1. Next, another important example, Fe3O4. Actually it exists in the form of FeO plus Fe2O3. In FeO, iron +2 oxidation state, this oxygen is having -2. Here, what happens for the oxygen? 2x minus 6 is equal to 0, 2x is equal to 6, x is equal to what happens? 2x minus iron oxidation state I have to calculate. 2x minus 6 is equal to 0 and 2x is equal to +6, x is equal to +3. Here iron is having +3 oxidation state. In Pb3O4, it exists in the form of PbO and PbO2. Here Pb is having +2, here it is having -2, and here it is having -1 oxidation state. Br3O8, and the best example and last year NEET question. Here, due to this oxygen -2, due to this oxygen -2, and that oxygen again -2, right? Here -2, -2, -2, -2, -2. So the oxidation state on this bromine will be here totally having -6. So this is having +6, -4. So this is having +4, and again this is having -6. This is about the calculation of oxidation numbers in different examples. Have a look at these, friends.